Welcome to Catch This. My name is Trudy Ray. This video is the second in a two-part series about HIV. In the last episode, Catch This episode 65, linked above, I went over the reasons for why we still don't have an HIV vaccine. As also discussed in that episode, we first became aware of HIV in the early 1980s. However, when did the virus actually emerge in humans? And where did it come from? In this video, I will tell the epidemiological story about the likely origins of HIV. Don't go away. There are two strains of HIV, HIV-1 and HIV-2. The vast majority of infections are caused by HIV-1, which is more common, more transmissible, and more pathogenic. HIV-1 is divided into four groups, M, N, O, and P. Of these, Group M is the oldest and most widely spread, and it is associated with the majority of global HIV disease. Soon after HIV-1 and HIV-2 were discovered, scientists learned that non-human primates in sub-Saharan Africa were infected with a variety of related viruses that were thereafter named simian immunodeficiency viruses, or SIVs. The development of new and improved molecular epidemiology tools in the 1990s allowed experts to analyze nucleotide sequences from large numbers of HIV and SIV isolates, eventually leading to the conclusion that HIV-1 and HIV-2 must have resulted from separate spillovers of SIV from apes and/or monkeys to humans. But how did we figure this out? Viral DNA sequences extracted from blood and tissue samples collected from human and non-human animals in various geographic locations and at different time points can be compared. Using a calculation technique known as a molecular clock, researchers can then estimate the approximate time it took for sequences collected at later time points to diverge from ancestral sequences collected at earlier time points. The more similar two sequences are, the more likely they are to share a common ancestor, while greater differences suggest a more distant evolutionary relationship. To clarify, consider the following human analogy. Full siblings share about 50% of their DNA because they share a set of parents, ancestors from whom they are only removed by one generation. In contrast, cousins only share about 12.5% of their DNA because their ancestral origin goes back 2 generations to their shared set of grandparents. Using SIV samples obtained from non-human primates in Cameroon and applying molecular clock techniques that take into account the rate of evolution of HIV, also discussed in Catch This episode 65, scientists eventually deduced that HIV-1 Group M evolved from an SIV-infected chimp somewhere in the southeastern region of Cameroon during the first 3 decades of the 20th century. This initial spillover from the chimp to the first infected human most likely involved direct blood-to-blood contact, the most efficient means of transmission for SIV and HIV. A hypothetical scenario known as the cut hunter theory involves a hunter scouring the Cameroonian forest for bushmeat around 1920, a practice that was very common in that region at that time. This man caught a chimp that, unbeknownst to him, was infected with SIV, and while dressing the carcass in preparation for later consumption, he accidentally cut and contaminated himself with the animal's blood. During this interaction, SIV infected its new human host and became HIV, a random event known as host switching. The hunter then later passed the virus to his wife during sex. Both husband and wife likely transmitted the virus to other people in the area through shared syringe needles used by mobile clinic workers who routinely visited Cameroonian villages to treat people suffering from various tropical diseases. Treatment of these diseases was mandatory and involved repeated intravenous injections of drugs with glass syringes and needles that were reused frequently without being sterilized. Newly infected people then traveled down the Sangha River, which connects southeastern Cameroon to Leopoldville, an important hub for trading and commerce, and the capital city of what was then the Belgian Congo, which is now Kinshasa in the Democratic Republic of Congo. This series of hypothetical events is consistent with the recovery of the oldest HIV-1 isolate extracted from the blood sample of a man who had died in Leopoldville, Kinshasa, in 1959. More evidence supporting this theory is the fact that the earliest strains of HIV-1 group M and all of its subtypes were later identified in Leopoldville, Kinshasa, and many of these strains and subtypes remain restricted to that area until today. Taken together, these facts suggest that Leopoldville, Kinshasa was the epicenter for worldwide transmission of HIV-1. The propagation of HIV-1 within Leopoldville, Kinshasa likely occurred through a combination of the growing local sex industry and clinics that specialize in treatment of tropical and sexually transmitted diseases using intravenously injected drugs. Eventually, the virus was exported to Haiti, likely through one or more of the numerous Haitian medical professionals who worked in the Congo around 1959-1960. A surge in gay sexual tourism in the 70s further advanced its spread from Haiti to the US, eventually leading to its discovery in Los Angeles, San Francisco, and New York. This story emphasizes the importance of a One Health approach to disease prevention, a strategy that is cognizant of the interplay between human health and the health of animals in our shared environment. Knowing how viruses are transmitted and where they originate helps us stop future outbreaks at the source and may even prevent spillovers in the first place. That's it for today. Thanks again for listening. Please subscribe. My name is Trudy Ray, and I'll see you next time on Catch This.